Okay, so let's get started. Bismillah ar-Rahman ar-Rahim. As-salatu wassalamu ala nabiyyina Muhammad wa ala alihi wa sahbihi ajma'in. Okay, so today we're going to continue for the second week of the data science course, and we will talk about a very important concept, which are the data structures. So as you already know, that the data structures are the entities where we can store data and manipulate data, like for example, accessing the data or storage of the data, removing data, and so on. And you've taken in the either CS101, CS102, or the CS213, the data structure course, the differences in terms of performance. Okay, either in access or modifying or inserting elements in the middle or inserting elements in at the end or in the beginning. So Numpy is kind of a versatile data structure that allows to make the computation in machine learning and deep learning very, very efficient. And even there are multiple other libraries that are built on top of Numpy, like for example, the PyTorch, they have the data structure tensor, which you are going to be introduced to also. And later on, we're going to talk about the panda frames or pandas. Okay, which is another data structure. Mostly it works like a relational table where you can load a CSV file and manipulate the data using a CSV file. So these two data structures, they have different purposes. We're going to start by Numpy, which is basically a multi-dimensional array, and pandas later on, which is like one table or two-dimensional array where you can store data and visualize, making statistics, descriptive statistics, or other types of manipulations. So let's get started. So what is Numpy? It's an open source library which represents the core library for scientific computing in Python, and it's used almost in every data science and engineering discipline. Okay, it represents a universal standard for working with numerical data in Python, and several libraries are built on top of Numpy, even pandas. Panda frame is built on top of Numpy. SciPy, this is for scientific computing. Matplotlib, this is for visualization. Scikit-learn, this is for machine learning. So all of them, they are built on top of Numpy arrays. And so it provides an object that is called ND array, which is n-dimensional array with homogeneous arrays object, n-dimensional array object. And it has different type of methods that allows you to manipulate this data, which we are going to introduce in this lecture today. So why we care about Numpy? So first of all, it has high speed. It provides more speed, so it can process extensive algorithms much more efficiently. It's written in C, and there is like a wrapper layer to use it with Python. It has very few loops because loops are the killing points in computing. Okay, and now you're going to see with Numpy, we're able to do a lot of operations without having to use for loops. And if you use for loops, you're going to have exponential time increase. Okay, we will be able to do broadcasting. We'll be able to do what we call vectorization. Okay, so we're able to even multiply matrices without making any single for loop. And this is the key for efficient computing. So the code becomes much clearer and it has much better quality. Okay, there are thousands of contributors working on Numpy to be fast, friendly, and also bug-free. So let's look at the structure. It's really important to understand the data structure of Numpy ND array. So, yeah. Okay. Look now, so from Python perspective, you as the user, you're going to see all of this messy stuff like as an n-dimensional array. Okay, like for example, this is a 3x3 matrix. But how it is encoded actually, it's following this structure. So first of all, it has a metadata, which is a description of the ND array structure. So the description starts with providing the type. Okay, so for example, here the type specifies the data type of the array. In this case, it's float 32. It means we can have a float over 4 bytes. Okay, because this also will tell you how much memory you are going to allocate for each element. And the dimensional count. So here we have 2. What does it mean? It's a 2-dimensional array. And in our case, it is a 3x3, and down below we will write the dimensions. So we have 3 rows and 3 columns. And we have strides. So strides here represent the number of bytes to step in each dimension. We have a dimension with respect to the rows and another dimension with respect to the columns. So each row, how many values it has? How many elements? 3 elements, 1, 2, and 3. So each element is encoded into 4 bytes because we have 32, float 32. So here, in order to go through a whole block of row, you need to have 12 bytes. And to go to the next column, you need to have only 1 4 byte, not 12. So this is 3 elements by 4 bytes, and this is only 4 bytes. And it's encoded in strides. Okay? It is encoded in the metadata of strides. And finally, you have the data here, which is a pointer to a contiguous block of data of the same type that is specified here. It points to the memory block that contains the actual data. So basically what you see as what you consider as a 2-dimensional array, it's basically a 1-dimensional array, but through these values, we're able to know where it is where is the column limit and where is the row limit as well. واضح? And let's see from the code. Now, this code illustrates all the different concepts, and it's available on the notebook. We can try it later on, and you can try it at home. So you can create a Numpy array. Are you able to see the code? Okay, so this is an array. We import Numpy as MP. So MP is like an acronym that we use for Numpy. It's the standard acronym. And instead of making numpy.array, you can just make np.array. And here we'll define the same two-dimensional array, which is a matrix here. Okay, 1, 2, 3. So this is how to make it. This is the first row. We write it as a list, and then comma, and then the second row we write it as a list, and the third row we write it as a list, and we specify the type. It's float 32. This is how we declare an Numpy array in Python. Yes.
There are different type of float numbers.
Different type of what?
Float.
Yeah, there is float 62, float 16, and int 8. And these are very important. These are very important because when the floating number increases, so this gives better accuracies for the machine learning, but of course it will induce the computation time and also the memory usage. Okay, 64 bits, you need 8 bytes to store them for every single element. Even if you write 0, you need to have 64 bits, which is 8 bytes. Okay, and also computation, because you need to calculate bigger amount of memory. So, but of course, in terms of accuracy, so one of the things that we do now in machine learning, I can anticipate why we are considering these type of things. We can train at high accuracy, so it will take long training time. But later on, for the inference, when we want to execute the machine learning code, we want to have fast response time. So basically, we make quantization. Quantization, it means reducing the complexity of the data type in order to execute faster. And sometimes you go up to int 8. Yes, up to int 8, so we lose a lot of accuracy. So people try to use quantization that does not compromise too much the accuracy. The accuracy is going to be compromised. But for example, if you can lose, let's say 5% of accuracy and you save a lot of time, okay, for example, it will execute 100 times faster. So in this case, it could be beneficial, especially for real-time applications that it requires to have an instant feedback. Yes?
Are they dynamic or static?
No, the data is static. You cannot change it. Once you specify the type, so the n-dimensional array, it cannot have, or Numpy array, it cannot have multiple type of data. It's only one type of data. Okay? It's not like, for example, a list. A list can have different types of data.
No, I meant in the declaration, do we have to initialize it, and that's the only initialization option?
No, the type, there is a default value. I think it's probably float 32 or 16. But you can change it. So when you specify it, if you make d type equal int 8, so you will have only array of integers.
No, I think it is the values of the.
Which value? This?
Yeah, 1, 2, 3, 4, 5, 6, 7. It can do it later instead of
Yeah.
just initialize and add the values later for the array.
Yes. It's possible. Yes, it's possible. This is just to illustrate an example. And now we can, for example, call array.dtype, okay, array.ndim, and dimension. So it will, number of dimensions. Okay, array.shape. This is we're going to use very frequently. .shape. The shape is going to return the shape, which is here 3 by 3. Okay, and it can be even more. It can have multiple shapes: 4-dimensional matrix, 3-dimensional matrix, and arrays.stride. And here, if you want to get the block of data, it's array.array interface data 0. But the data, we can get it much easier than this. Is just how to access this full information over here. And this is a Python list. So Python list is completely different if we want to illustrate the difference with a Python list. Okay, so the difference between Python Numpy array and Python list is substantial. Okay, so Numpy is much more efficient in memory, in storage. However, the Python list is memory intensive. Here we don't specify even the type. Okay, and here it points to a block of pointers, whereas the Numpy array will have a contiguous block, one contiguous block, not multiple blocks. So here we have a block of pointers. So it makes it much more difficult to manage. I'm going to show you a code that shows the difference. And here it's going to be stored into a contiguous block of information. Okay? Once you specify the size, this block will be allocated in a contiguous manner in the memory. So you don't have the information scattered in different locations in the memory. And this is what it makes it efficient in terms of processing. So this is the code that shows the difference between Numpy and Python list. So here we take a big size to show the difference. We create a Numpy array using mp.arrange. So this is one of the ways, yes. So this is going to create values, for example, if you make size equal to 10 from 0 to 9. So it will create 10 elements. Okay, dot arrange. Yes, and the same thing we can do with list. So we can make range size, and here we create a list. And we can check the start time with, using time.time, and then we multiply the NumPy array. So here we will look at the time taken to make the multiplication by 2. We're going just to multiply all the elements by 2, either for the NumPy array or for the Python list. So this will do the same thing. And we can see the difference now. If I go to the notebook, let me increase the size, zoom in. Look at the difference. 0.005 for the NumPy array and 0.16 second for the list. So obviously we cannot use list for scientific computing.
30 times faster.
Yes. So NumPy array was designed to provide efficient, computing, both in memory and also in terms of computations. Because later on in deep learning and machine learning, we are going to deal with n-dimensional arrays with large amount of data, at high precision sometimes. So we need to have very high efficiency for the computation. Okay, so this is just different representations of the NumPy array. That's one is a simple representation. We have the header here showing the data type, but this one is comprehensive. It shows all the different elements. Here also it's an illustration of the stride. Okay, so you have one stride to jump a full row and 4 bytes to jump only one column. That's a summary of the same data, and how to get them. A very important aspect in NumPy array is the concept of access. And this is crucially important. The concept of access, it means on which direction we are going to consider the elements. So now, if we have one-dimensional array, we have only one axe. We have one row and multiple columns. So axis 0, it's basically specifies the rows, the columns. So what is the shape here? We can specify an array of shape for and only one element. So if we write like shape like this, it means it's one-dimensional array with 4 elements, with 4 columns. This is one-dimensional array. Now with two-dimensional array, we will have 2 axes. Let's say the x and the y. Okay. So axis 0, this represent the rows, and axis 1 and represent the columns. Okay. So sometimes, for example, sometimes you would like to make the sum over the rows. So now, for example, if I want to make the sum over axis 0, so what I will do, I will sum 5 plus 2 and 9 plus 1. So that will be one element. And then 3.0 and 0.1, that's another element. And then 4.5 and 0.3, that's another element. Now, if I would like to make the sum on axis 1, what I will do, I will sum these 3 numbers. Okay? Because sometimes you say, I would like to make NP array.sum on axis 0 or on axis 1. So it will provide 2 different sums. If you make NP array.sum, so it will sum all the values of the NP array. If you make, for example, NP array.sum on the axis 0, so it will make the sum of all rows, for the single column, or it will make for the single row. So same thing, if we have 3-dimensional array, 4-dimensional array, we will have more axes. Okay, now this is like the x-axis, y-axis, and z-axis, or something like this. So we usually call it axis 0. So usually axis 0 is the rows, when we have multi-dimensional array. If I say, for example, make the sum over all the rows, so when you listen about rows, it's axis 0. Columns, it's axis 1. Okay, and then we have axis 3. Usually now in computer vision, we have a picture. It's basically, it has three axes or 3 channels. So axis 3 or axis 2 in computer vision, it's basically the channels. We have red, green, and blue. So every channel, it has a 2-dimensional matrix, which contains values between 0 and 255, or can be normalized to 0 and 1. Is it clear what I'm saying? Okay, so usually in computer vision, we have 3-dimensional array, where every picture, will have axis 0 and axis 1. For example, this is the picture for the blue color, and then we have another picture for the green color and for the red color. So axis 2 represent usually the channels. And in deep learning, we add another axis, which is the batch size, because when we have a large amount of data, we are going to process it into batches. just to avoid to have memory overload. That's the fourth dimension. We can have 4 dimension, 5 dimension, depending on the computation requirement. Okay, so you can think about 3D array as something similar to this one. We have axis 0, it's for the rows, specify the rows. Axis 1, specify the columns, and axis 2 usually denoted as the channel axis. Is it clear? And this is here small code that shows the differences. So this is to create 1-dimensional array. We can create it like this, 2-dimensional array, same as here, and 3-dimensional array, okay, as you can see. And we can demonstrate access operation with broadcasting. Look now, what we can do. And for this, let me go to the notebook to illustrate these concepts. It's basically here. And let's make it step by step. No, this one, it's not for, this is for the access, okay. Let's create the first element. Okay, so this is 1-dimensional array, and we can visualize it. Okay, and this is a 2-dimensional array here. We can visualize it. So we can do like this, or also you can make print. But when you use a print, it will have a different display without array. Okay. So if you want to show the whole object, you can just show it like this. So this is the object representation. And 3-dimensional array. Okay, it will give us the following. Okay. So look now, this is very important concept of Numpy. This is the strength of Numpy. So the first operation here. Okay, what is range 3? Okay, let's illustrate this one. So it will give you an array 0, 1, 2. If you make range 10, yes. Okay. Look at this nice feature, what we call broadcasting. So what we will do here, we're going to make the sum of this array. Okay, let me call it, for example, A1. And here I will make A1, which is an array, plus 5, which is an integer. Okay, so here we have a kind of operator overloading, or here in the context of Python, we call it broadcasting. So this will give what? What it will do here? Yeah, it will add 5 to each element. Yeah. Okay, this is called the broadcasting. What does it mean? One int will broadcast over all the elements. Okay, and this is a nice feature. You don't need to make a for loop to add one by one like you did in data structure in Java, for example. In Java, you need to make a for loop. You don't have this kind of broadcasting capability. And this is one of the reasons, yes, that Python is #1 for scientific computing because of these different type of facilities. Yeah. Another one, okay, operation here, operation 2, np.1. So np.1 is going to create numbers of, so 3 by 3 matrix that contain only 1. Something missing. Yeah, and there are also zeros, same thing. And I think there is also .random or rand. Yeah. No problem. I have it in my notebook. Just I don't memorize the syntax. So okay, now np1 3 by 3, and here look, we specify the int type. Okay, that's good to show the int type, the effect of int type. Now if you do it like this, it's 1. Now if I do float 32. It's not, okay. Yeah, it has to be text. Float 32. Now it becomes 1.0. Okay. And plus np range. Okay. So let's make it. Okay. Now let me remind you of this one. np.range. Now look. It will add every element. Yes, to each row. Okay, let's look at operation. What will happen? So 1, 2, 3, 1, 2, 3, and 1, 2, 3. So this is called also broadcasting. And look now, if I make a read, there should be some compatibility in the size. Yeah, MP range dot 4. Now here, for example, if I make MP range dot 4, no, because it says you cannot broadcast together with shape 3, 3, and 4, 1. It's not compatible. We don't have compatibility.
Out of range.
Yes. And one of the most critical aspects in machine learning and deep learning when building models is to take care about the sizes, compatibility of the sizes. This is one of the most critical aspects.
So what if you have NP dot range 2, like one less value? One less value.
Same thing, it must be compatible because now it's expecting, look now, if we make, for example, MP range 2, it's not going to work. Now, if you make 4 and you specify here 4 elements in the row, no, maybe number of rows, number of columns. Now, the number of columns must match. It's the number of columns because we have here 4. Look now, it's matching. It must match with the number of columns. Now, if you make 4, look, 3, 4. Okay, now we have 4 elements in this row and 4 elements in this row. So in this case, you can do the sum. You can do also not only the sum, but also multiplication. Yes, even multiplication will work. Okay, division. Sometimes there is division. Yeah, division works also. No. Yeah, you can divide by, or even by one number. Very flexible.
Oh, he's also divided 0 by 1 k with 50.
Yes. Okay. So it's very powerful. It's a very powerful library, okay, that provides a lot of functionalities here. So this slide summarizes all the different functionalities. It's like a cheat sheet for Numpy array. You can print it with you so to get used or to understand all the different types of operations on Numpy. Okay. So let's complete the code here just to look at the different other functionalities. Now this is a list, so how to create a Numpy array, we can have different ways. And basically Numpy array is a good replacement of MATLAB. Have you heard about MATLAB? That was the #1 scientific computing platform. It's paid, very expensive. It's known about its M files, which are very similar scripts to Python. But now almost everything in Python, in MATLAB, you can do it in Python. Unless if we talk about the toolboxes in MATLAB, they are sophisticated. Probably these are very advanced. But for scripts, now MATLAB can do pretty much everything. Okay, so we can start from a list. We can create a Numpy array starting from a list. Okay, so this is now its equivalent. It will convert or it will cast the list to a Numpy array. Okay. So Numpy, it has a constructor, and this constructor has different attributes or arguments. So for now we have the D type, which represent the yes. So this is pi tuple. So we can also convert a tuple to an array. So same thing here. We convert two-dimensional list into also a Numpy array. Okay. So you can convert pretty much everything to a Numpy array. There is one example here. So here we have okay, we made this example of scientific computing. And these are different ways on how to create a Numpy array. Okay, yes. Converting a tuple, converting a list, making a range. So this creates 10 values from 0 to 9. Okay. And ones or zeros, np.1s and p.0s, it creates either elements with 1 and elements with 0. So you can copy, you can make np.copy, okay, and this will be a replicate array. You can create an array from another one, and this will be into a different memory, okay, to different memory spaces. You can concatenate, for example, I have a list and a tuple, concatenate both together. So what will happen here? You have a list and you have a tuple, so you will have an n-dimensional array which contains all the elements. واضح? Okay. So you can go through all of these things. You can make MP from buffer. You transfer even an hexadecimal into a Numpy array. Look, this is the hexadecimal of 01, 02, 03, 04, and where it is located. It's not showing. Yeah, it's this. Yeah, this one. Look, it's of type int 8, unassigned int 8. Okay. Let me continue. Please make sure to go through all the notebooks, okay, and try different examples. Try to modify the code, make errors, observe the errors. This is really important. Okay, so yeah, an important thing is about the shape. If I tell you what is the dimension, if I ask you a question, give me the dimension of the NumPy array. So first of all, you will do np.shape. Okay, this is the nt array. It has 2 rows and 4 columns, and then you can make shape 0 to only return the number of rows. Okay, and shape 1 is the number of columns. Shape 3 is the number of channels in case of a computer vision, for example, context. Okay, this is another example. Okay, we have a list. We convert it to a NumPy array, and then we can get, look, this is a 3-dimensional array. Okay, the shape here is 3-dimensional. This is the number of rows, number of columns, and number of channels. Look now, this is how many rows we have? 2. We have 2 columns and 3 channels. So this is 1 and this is 2. This, okay, and you have, this is a row. So these are rows and these are columns. 1, 3 is a column, and then these are channels. Yeah, the representation is not intuitive, by the way, but this is actually, you can understand the representation by looking at the shape, okay, not looking at how it looks like. Yes. Okay, and of course we can access the number of rows. Look, I put here explicitly the number of rows, so for you to understand, 0 is rows. Access, and this is what we talked about them before, the access. Okay, the access 0 is the rows, access 1 and access 3 is the channel, number of rows, and also sometimes we call it the depth, al-'umq. Okay, if it's not in the context now, in general context in computer vision, we call it the depth. You have the number of rows, number of columns, and the depth. It's important to understand these technical words. Okay. Okay, np depth. So you can force the D type. Okay. Like for example, making the D type to float 32. We can make it as a complex also, and extracting all the different information like the shape and the dimension. We have made all of this, so I can go a little bit quickly on this. We talked about also the different creation functions. You can use arrange, okay, in different ways, by the way. You make arrange 10, so it will result into this array. Yes, you can specify the starting and the ending limits. Start from 3 and stop at 10, so it will make you from 3 to 9. Of course, 10 or the stopping value is not inclusive; it's exclusive.
Can you also have like a step value? Like,
Yes, I think so. Yeah, step. Yes, you have here a step value. Yes, you can have a step value, okay, between 2 and 3, and you can have a shape. So we can create also NumPy using lean space. So what does it do? It will create, for example, value from 1 to 4 and 5 elements, and it will make equivalent distance between the values. This is what we call lean space. Okay, let's make something intuitive. For example, I make 4. So create 1, 2, 3, 4. Okay. Yes. Now, if you make 5, it will be equal. Yes. Look now. This is 175. Between this one and this one, it's 0.75, and this is 0.75, and so on. Okay. So it will make points at equidistance. Okay, equivalent distance between the different points, and you can specify how many values you want to stop at. Okay. This is what we call lean space.
So you said the axis, the first slides. How can I know which axis I'm moving to?
Where?
In the slide you said that axis 0 is for the columns.
Yes.
And axis 1 is for the rows.
Yes.
How can I know which one I'm referring to?
You can specify the axis. For some operation, we need to specify the axis. Okay, let me show you an example. You don't know unless you specify it. Otherwise, if you don't specify the axis, it's going to consider the whole NumPy array.
So when I get it from the shape,
Yes.
shape function, it's x0, then axis 1, axis 2?
Yes,
Okay.
it's ordered. By the shape is ordered. And we will have some examples here where to work with axis. Yes, I think in vectorization. Just a moment. Okay, I didn't put here axis. But for example, okay, let me make a NumPy array. I want a three-dimensional NumPy array. Where did we make it? It's this one, for example. I will call this NP1. NP1. Look, now if you make NP1 dot sum, it will sum all the values. Okay? If we make now axis equal 0. Sum of the rows. 0 2, 0 2 plus 0 2, 0 6. And here 0 2, 0 2. So 0 6 for all. Now if you make it now for 1, what will be the result? Give me the result.
The first row, then second, and third.
Yes. So what will be? What will be the shape?
3 by 1. Like
3 by 1, okay, and all values will be 0 8. واضح? Because it will make the sum of all column values.
You won't give a vector like this.
Hmm?
You won't give a vector.
Vector?
Yeah.
Yeah, it's a vector now. It's one-dimensional array. Look now. If you make dot shape, it's 3. Okay? And you can make dot 0. Okay. So this is an example showing the impact of axis. And this is something pretty much used in machine learning computing. Okay? Especially when you do things in batches. Okay, if I make 2 here, what will happen? We will have error because we don't have this dimension. Okay. So I'm going to stop here right now, and tomorrow we'll continue and complete NumPy. But it's good, I'm going to share with you the notebooks and the slides. Have a look at everything, and tomorrow we complete our discussion, inshallah. Okay. This is the most important data structure ever. Okay, you'll have it all along your AI and data science career.